A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine for a second that every time you had a brilliant idea or a breakthrough conversation at work, the second you walked out of the room, a giant industrial shredder ate every note, every whiteboard drawing, and every memory of what was said. You'd be starting from scratch every single morning. That sounds like a corporate nightmare, but Herman, that is exactly how we are treating the billions of AI conversations happening every single day. We are living in the era of the great AI data lobotomy.
It is a massive blind spot, Corn. We spend all this time obsessing over the prompt, the RAG pipeline, the vector embeddings for the input data, but the moment the model spits out an answer, we treat it like a Snapchat message. It's ephemeral. Herman Poppleberry here, by the way, and I've been diving into the leaky bucket problem of AI outputs all week. Today's prompt from Daniel is about exactly this. The neglected world of AI output storage and the tools finally trying to give these models a long-term memory.
It's funny you mention the input obsession. It's like being a chef who spends $10,000 on organic hand-massaged kale, but then serves the meal on a plate made of ice that melts before the customer can finish the first bite. We're losing the most valuable part of the interaction, the actual reasoning and the refined answers. Oh, and before we get too deep into the weeds, a quick shout out to our scriptwriter for the day. Google Gemini 3 Flash is powering this conversation. It's fitting, considering we're talking about how to make sure what Gemini says today isn't forgotten tomorrow.
The stakes are actually much higher than just saving a chat transcript. We're talking about the difference between a stateless tool and a stateful partner. If you look at the NIST AI Risk Management Framework update from January 2026, they really hammered home the need for audit trails. In regulated industries like finance or healthcare, if an AI gives a customer advice, you can't just say, "Oh, the model said something, but we didn't save the trace." You need to prove what happened 3 months ago.
Right, because the ghost in the machine told me to buy that stock isn't a great legal defense. But beyond the suit and tie compliance stuff, what actually happens to that data if we do save it? Most people think of logging as a boring text file sitting in a digital basement. How do we actually turn a mountain of raw logs into something that doesn't just take up server space?
That's the old way of thinking. Now, we're seeing the rise of observability and logging platforms that treat outputs as high-value datasets. Think about LangSmith, which LangChain launched back in 2023. It's the industry standard for tracing because it doesn't just record the text, it captures the entire trace. The logic chain, the retrieved documents, the latency, and the cost. When you have 10,000 traces, you don't just have a log, you have a goldmine for fine-tuning a smaller, cheaper model to act exactly like your big, expensive one.
It's like recording a basketball game not just to see the final score, but to analyze every step the players took to get there. I've looked into LangFuse and Helicone too. They seem to be making a big splash in the open source world. What's the trade-off there? Are people choosing them just to save a few bucks on SaaS fees? Or is there a deeper technical reason to go open source for output storage?
It's a mix of both, but control is the big word there. If you're a developer building something sensitive, you might not want your AI's thoughts sitting on someone else's server. LangFuse has this SDK-first approach that makes it really easy to integrate into existing pipelines. Helicone is fantastic for managed services where you just want a dashboard to see why your API cost spiked at 3 in the morning. Then you have BrainTrust, which came out in 2024. They're positioning themselves as the enterprise-grade solution. They focus on high-speed logging and automated evaluation. They aren't just saving the output, they're running tests against it in real time to tell you if your model is getting dumber or more biased over time.
I love the idea of automated evaluation. It's basically an AI watching the other AI to make sure it's not hallucinating. But how does that work in practice? If the primary AI makes a mistake, does the evaluator AI just flag it? Or can it actually intervene before the user sees the error?
In a sophisticated setup, it can do both. You have what's called a guardrail layer. For example, if the output log shows the AI started talking about a competitor's product in a way it wasn't supposed to, the evaluator can trigger a rewrite or a warning, but more importantly, it allows for versioning of your outputs. You can see that Model A gave a better answer on Tuesday than Model B gave on Wednesday, and the system logs why. It's about creating a feedback loop where the outputs of today become the training data of tomorrow.
But let's talk about the backbone of this. If I'm saving millions of these outputs, I can't just stick them in a giant Excel sheet. We're back to vector databases, aren't we? But you told me once that vector DBs were for the input, the RAG stuff. How does that flip for outputs?
It's what some people are calling reverse RAG or output indexing. Think about Pinecone's serverless architecture or Rust-based tools like Qdrant. Instead of just indexing your company's PDFs, you embed and index every single successful answer the AI has ever given. When a user asks a question, the system first checks, have we solved this before? If the answer is yes, it pulls the previous high-quality output. This ensures consistency. There's nothing worse than an AI giving two different answers to the same question within 5 minutes.
That sounds like it would solve the goldfish brain problem where the AI forgets your preferences the second you start a new thread. I've noticed that with some of the agents I use, they're brilliant for 10 minutes, and then they act like we've never met. It's insulting, really. I put work into these relationships, Herman. It's like the AI has a memento condition where every new chat window is a complete reset of its personality.
Well, that's where the memory layer projects come in, and this is where it gets really cool. This is different from passive logging. We're talking about active, long-term brains for AI. The big name right now is Mem0. It's got something like 48,000 stars on GitHub. It doesn't just store text, it builds a multi-store architecture of user preferences. If you tell an AI you're allergic to peanuts in a chat about cookies, Mem0 makes sure the AI remembers that 3 weeks later when you're asking for a dinner recipe. It's creating a persistent user profile that follows you across platforms.
Wait, so if I use a coding assistant in my IDE and then talk to a travel bot on my phone, Mem0 could potentially link those? Like the travel bot knows I'm a Python developer because I mentioned a bug to the coding bot earlier?
It breaks down the silos between different AI applications. Instead of each app having its own tiny isolated memory, Mem0 acts as a centralized memory graph. It uses a hybrid approach, storing specific facts in a relational way while keeping the vibe or semantic meaning in a vector store. It's trying to mimic how human memory works. We remember the specific fact that it rained on Tuesday, but we also have a general feeling that the week was gloomy.
So it's basically a digital burn book. But for my preferences, Korn likes his coffee black and his code commented. I can see how that changes the game for personalization. But what about the more architectural memory? I've heard you mention Letta before, the project formerly known as MemGPT. How does that differ from just a preference log?
Letta is fascinating because it treats memory like a computer treats RAM and a hard drive. It uses virtual context management. Instead of trying to cram everything into the model's limited context window, which is like trying to read a library through a magnifying glass, it swaps relevant pieces of past conversations in and out of the prompt dynamically. It gives the AI an infinite context window because it knows how to go fetch the right memory at the right time.
It's funny, we spent years trying to make the context windows bigger, from 8,000 tokens to 1,000,000, and Letta is basically saying, actually, just get better at filing. It's the difference between carrying every book you own in a giant backpack versus just knowing how to use a library card. But I have to ask, doesn't that fetching process add a lot of lag? If the AI has to go find a memory before it can even start thinking, aren't we sacrificing speed for brains?
That is the big engineering hurdle. If the retrieval part of the memory takes 2 seconds and the generation takes 2 seconds, you've doubled your latency. That's why Letta and similar projects are focusing so heavily on tiered storage. They keep the most recent or most likely relevant memories in a hot cache and push the older stuff to cold storage. It's very similar to how your computer's CPU uses L1 and L2 caches. They are essentially building a hardware architecture, but in software specifically for the large language model's thinking process.
It reminds me of how humans work. I don't need to remember what I had for lunch 3 years ago to have this conversation, but if you mention a specific restaurant we visited back then, my brain swaps that file into my active consciousness.
Precisely. And then you have ZEP, which is temporal aware. This is a nuance most people miss. Facts change. If I tell my AI in 2024 that I live in London, but in 2026 I tell it I've moved to Jerusalem, a standard vector search might get confused and pull both addresses. It might say, you live in London and Jerusalem, which is logically messy. ZEP understands the win. It realizes that the newer information should probably override the old stuff, or at least provide context for the change.
That's a huge distinction. Most AI memory is just a flat pile of data. Adding a time dimension makes it feel much more human. Think about a legal case or a medical history. The order of events is everything. If the AI suggests a treatment based on a symptom you had 5 years ago, that's already been cured. That's not just a hallucination, it's a failure of temporal logic.
Right. And ZEP also does something called automatic summarization. As a conversation gets longer, it doesn't just store every word, it periodically condenses the dialogue into a summary of key points. This keeps the memory efficient. It's like how you might forget the exact wording of a 3-hour meeting, but you remember the 3 key decisions that were made. Without that compression, the storage costs and the retrieval speeds would eventually become unsustainable.
Now, let's move from the brains to the tools, for us mere mortals. I've been using Pieces for developers lately. It's this workflow co-pilot that just grabs stuff. I'll be having a conversation with an LLM about a weird Python bug, and Pieces just snags the code snippet, tags it, and saves it. I don't even have to think about it. It's almost like having a personal secretary who only cares about my terminal output.
Pieces is a great example of output management. It's solving the human end of the leaky bucket. Most of these other tools we've discussed are for developers building apps, but Pieces is for the person using the app. It uses on-device AI to index your snippets, which is a big privacy plus. Another one is dust.tt. They're focusing on teams. Imagine an entire engineering department using AI. Usually, those insights stay trapped in individual browser tabs. Dust indexes those outputs and makes them searchable for the whole company. It turns those individual aha moments into institutional knowledge.
I've seen teams where 3 different engineers were all asking ChatGPT the same question about a legacy codebase. They each got slightly different answers, and none of them knew the others were even working on it. That's a massive waste of tokens and time.
As one person in the AI community put it, the most valuable data in your company isn't your old PDFs from 10 years ago, it's the 10,000 hours of expert AI collaboration happening in your Slack and IDEs right now that you're currently just deleting. If you can capture that, you're essentially capturing the thought process of your most expensive employees.
That quote hits hard. It's the collaboration, that's the data. It's not just the final code, it's the back and forth where the human corrected the AI, and the AI refined the logic. That's the reasoning trace that companies should be desperate to keep. If I'm a CTO, I want to know how my best senior dev is using AI to solve problems, so I can use that to train the juniors. I want to see the wrong turns the AI took, and how the humans steered it back on track.
And that's the data flywheel that Braintrust and LangSmith talk about. You use the stored outputs to generate synthetic data. You take the best outputs from a massive model like Gemini 3 Flash or GPT-4, and you use them to fine-tune a tiny, hyper-specialized model that runs on a phone but performs at a frontier level for your specific use case. This is the distillation process. But you can't distill a spirit if you let the liquid evaporate the moment it leaves the still. You have to capture the output.
So, why has it taken us this long to care? We've been living in the year of the chatbot for what feels like a decade now. Why is output storage the neglected middle child of the AI stack? Is it just because we were all too dazzled by the magic of the initial response?
I think it's a mix of technical hurdles and a gold rush mentality. In a gold rush, everyone is focused on the mining, the input, the prompts, the models. Nobody is thinking about the vault to store the gold until they realize their pockets have holes in them. Technically, it's also hard. Storing and indexing millions of dynamic, conversational traces is way more complex than storing static documents for RAG. Plus, there's the privacy headache. If you save everything, you're saving a lot of PII, personally identifiable information, that you then have to manage and protect.
That PII part is scary. If I'm a bank and my AI assistant is helping a customer with their mortgage, that conversation is full of social security numbers and bank balances. If I save that trace to help train my next model, am I accidentally creating a massive security liability?
You are, unless you use tools that have automated PII scrubbing. This is another reason why output management is becoming a specialized field. You need a layer that says, save the logic of the mortgage calculation, but redact the customer's name and account number. Doing that at scale, in real time, across millions of logs, that's a multi-million-dollar problem right there.
The pockets with holes analogy is great. I'll give you that one, Herman. But it feels like the holes are finally getting patched. If I'm a developer listening to this right now, and I realize my app is stateless and my users are frustrated because the AI keeps forgetting their name, where do I start? What's the starter pack for AI output storage?
Step 1. Stop throwing data away. Even if you don't have a sophisticated RAG on output system yet, start logging. Use something like LangFuse if you want to host it yourself, or Helicone for a quick managed setup. Just get the traces into a database. Step 2. Evaluate if you need memory or just logs. If you're building a personal assistant or a long-term agent, look at mem0 or ZEP. They have APIs that make it surprisingly easy to add a memory layer to your existing LLM calls. It's often as simple as passing a user ID with each request so the system knows whose memory to pull from.
And for the non-developers? The people just using these tools? I guess the takeaway is to look for platforms that actually let you export or index your work. Don't get locked into a black box where your best ideas are trapped in a scrollback window that eventually disappears. Use things like Pieces or Rewind.i that actually keep a local record of your digital life.
We're moving toward the Locomo benchmark, long-term contextual memory. It's a new standard for measuring how well an AI recalls and stays consistent over time. In 2026, accuracy is the baseline. Consistency and memory are the new frontiers. If an AI can't remember what we talked about yesterday, it's not an agent, it's just a very fast typewriter.
A very fast typewriter that's prone to lying. I think I'd prefer the partner. It's wild to think that we're basically building a file system for AI reasoning. Without a place to save its work, an agent can't perform a multi-day task. It's like trying to write a novel, but you're only allowed to see the sentence you're currently typing. If you can't look back at chapter 1, you're going to have a lot of plot holes by chapter 10.
That's the perfect way to frame it. For AI to move from chat to execution, it needs a hard drive. It needs to be able to save as and open recent. We are finally seeing the operating system for AI being built, and output storage is the disk drive. Think about how much more productive you are because your computer has a documents folder. AI needs that same structural persistence to be more than just a novelty.
Well, I'm glad we saved this conversation, at least. I'd hate for all your temporal-aware wisdom to go to waste, Herman. I think we've covered the spread from the logging black boxes, like LangSmith, to the long-term brains, like mem0. It's a lot to chew on, but the direction is clear. Stateless is out, stateful is in.
It's the only way forward. We've reached the limit of what one-shot prompting can do. The next leap in AI capability isn't going to come from a bigger model. It's going to come from models that actually know us because they've been paying attention and, more importantly, because they've been taking notes. We're moving from the era of general AI to contextual AI.
Contextual AI. I like that. It sounds less like a robot and more like a colleague. But before we get too sentimental about our digital partners, let's remember that they only know what we tell them and what we choose to save. It puts the responsibility back on the user and the developer to be intentional about what's worth remembering.
That's a great point. Not every conversation is worth a permanent spot in the memory bank. We also need forgetting mechanisms. Just like the human brain prunes away useless information to stay efficient, AI memory systems will eventually need a trash can or an archive feature to keep the noise from drowning out the signal.
Taking notes, a skill I'm still trying to teach you, Herman. But we'll get there. This has been a deep dive into the forgotten layer of the AI stack. If you're building in this space, or just tired of your AI having the memory of a goldfish, hopefully this gave you some pointers on where the industry is heading.
It's an exciting time. The tools are maturing so fast. I'm already looking forward to seeing what the next iteration of Mem0 or Letta looks like by the end of the year. We might be looking at a future where your personal AI has a more reliable memory than you do.
That's a low bar for me, Herman. A very low bar. Before we wrap up, big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that power the generation of this show. They're the ones making sure the plumbing for our AI-human collaboration actually works.
If you found this useful, or if you've got a weird prompt of your own about the future of AI, send it our way. We're at show@myweirdprompts.com. We actually read every single one, and we might even feature your prompt in a future deep dive.
And if you're enjoying the show, do us a favor and leave a quick review on your podcast app. It genuinely helps other people find these deep dives and keeps the show growing. It's the best way to support the stateful growth of this community.
Find us at myweirdprompts.com for the RSS feed and all our previous episodes. You can browse our entire history. We've made sure it's all properly indexed and stored for your convenience. This has been My Weird Prompts.
See you in the next one. Stay curious and maybe write some of this down.
I've already indexed it. Corn. We're good. I've got a backup on 3 different servers and a local vector store.
Of course you have. You're the king of persistence. Bye, everyone.
It's goodbye.
This episode was produced using Google Gemini 3 Flash. Text to speech by Chatterbox.
Thanks for listening to our show.